Welcome students. Come to the next session of alloy steels and designation. In last session we have discussed about the basic terms related to iron carbon diagram and classification of steels based on carbon content, that is hypoelectrode steels and hyperelectrode steels. Now the next classification of steel is based on or how the steels are classified are as shown over here. That is first one, amount of carbon, that is how much amount of carbon we add in steels. Next one, amount of alloying steels, that is how much alloying elements we are going to add other than carbon and iron. Next one, amount of deoxidation, that means how much oxides we are going to remove from the ions or steels. Next one, the grain coarsening, that is what type of microstructure content we have or how much is the size of grains for different types of steels. Next one, methods of manufacturing, that is how the steel is manufactured based on that. Next one, depth of hardening, that is whether the structure or the steel is too hard or whether the steel is too soft based on that. And next one will be the application, that is for what purpose we are going to use the steel. Based on that we have classified the steel. Next one, we have classification based on types of carbon source, that is carbon content. So first one is low carbon steel, that is carbon content based, as we know that we suppose we have an carbon diagram. This is detected point. So low carbon steel contains carbon starting from 0.008% to 0.3 somewhere over here. Next one is a medium carbon steel starting from this point to somewhere over here, that is classification of from 0.3 to 0.6. We call this as medium carbon steel. This is low carbon steel, and remaining content up to 2%. That means over here we have high carbon steel. So this is the classification based on percentages. Next, following are the details based on clean carbon steel classification, that is summary of low carbon steel 0.008 to zero zero 0.3. So what are the properties? It is compared to all other two types we have, it is too much soft, ductile and malleable, and it is named as mild steel. Similarly, medium carbon steel has intermediate properties starting from low and high carbon, and it is most probably used for machinery type, so it is called as machinery steels. Next one is high carbon steel, which is used preferably for tougher applications because it has harder properties due to maximum carbon content, so it is also sometimes called as tool steels. Now what are the different applications? For low carbon steel, preferably used for wires, rivets, screws. Medium carbon steel preferably used for axles, forging, dies, and high carbon steel is used for punches, cutting, and drills. So, what are the names or classifications? AISI 1030 is used, or is nothing but low carbon steel. That is first last two numbers indicates 0.3% carbon. Medium carbon steel, that is AISI, contains carbon of last two words, as we know that 0.4%. Similarly, high carbon steel, that is HSS, high speed steel. Next classification is based on alloying element, that is how much is the alloying element. If alloying elements are added and contains less than 10%, we classify them under the category of low alloy steels, whereas the alloy steels which are added more than 10% we classify based on high alloy steel. Next classification is grain coarsening. Preferably the grain coarsening indicates if we have a crystal microstructure and if we have a bigger grains. So method followed for our steel used for high grains, we call it as grain or coarse grain steels, and if we have a steel with very fine crystal structure, that means maximum number of grains within the same size, we call it as fine crystal or fine grains Next is classification based on oxidation or deoxidation. That is, when oxygen or oxides are removed from the steels, we classify based on this. If none of the oxides are removed from the steels, we call first category as reamed steel. Second one, when total oxides are removed, that is, iron oxides are formed during fracturing. So when this steels, when oxides are removed, we have, or we call this as keeled steel. And when semi, that is, some of the oxides are removed, we call it as semi-keeled steel. So this is the classification based on oxide. Next we have classification based on manufacturing, that is how it is found. First one, that is, if steel is manufactured in open hearth, it is basic open hearth, we call it as basic open hearth steel. Next, if based on electric furnace, we classify it under electric arc furnace. Next one, basic oxygen process, that is oxides are the process of oxide removal, basic oxygen. Next one, acid open hearth and the acid base cement. Next one, based on depth of hardening. All steels doesn't have same type of hardness. So based on hardness, that is, if usually low carbon steels are non-hardenable, so it comes under the category of non-hardenable steels. Medium carbon steels are shallow hardenable, sometimes maximum hardenable. We have shallow hardenable steels and deep hardening, that is high carbon steels. We come under the category of deep hardening, that is maximum hardness. Test. And last one, based on the application, that is for what purpose you are going to use the steels. So we classify steels as first one, boiler steel, case hardening, corrosion, deep drawing steel, electrical purpose if we use it, electrical steels, structure purpose, we have structural steel, tools. So remaining part will continue in the next session. Thank you for today's session.